Before we get started, I really quickly want to tell you I've been on the road for 4 weeks and I've got a souvenir of a cold. So I'm going to use the mic so that if I start like coughing up a lung, I can move the mic away. So we're going to talk about livable cities. And so what I am is a quantitative storyteller. And what that means is I look at the friction between perception and reality. And I got that saying from Michael Lewis because he says that's the seed to telling compelling stories. And, you know, Mappamundi is, you're probably familiar with, this medieval map that predated Columbus or any voyages, but it was pretty accurate. It's kind of interesting, though, the projection, you know, what projection is that map? They list it as God. So can't argue with that. What makes a city livable? We're talking microeconomics when we look at a city. Macroeconomics is when we look at that city and we combine it with the environment. And I like to include like a personal disclosure and conflict of interest when I'm speaking to groups. And this is mine. You know, I look back at the ecosystem and how limited it is. It's a finite resource. And many of us in technology, we don't take the time to quantify it that way, but we need to start thinking about it because if we're using finite resources exponentially, that is not something we can continue to do. We are the only species that extinct species. And what I'm using this to tell us is, you know, we have to frame things. I like to use the city because that's the level we are when we're stripping out resources and we're impacting our climate around us. And we need to slow down and start looking at the metabolism of cities and how we can change them. And we don't necessarily have to be destroying the environment we live in, because sustainability really isn't about this great thing that we can all say, look, we're sustainable. It's something we were supposed to be doing back then, you know, on the balance sheet. So what we're doing now is trying to think forward and to think proactively. And, you know, the city is just that frame of reference that makes it tangible to so many. And then we look at infrastructure. Infrastructure is also something that has a power curve associated with it that we can, you know, impact. So there is possibility. You know, I'm not here to be the doom and gloom geospatial person that's saying the end of the world is coming. You know, there's a lot of things we can do, and there's a lot of innovation still to be done. And we can go back into these environments and clean up the water, clean up the systems. You know, we haven't built out our renewables to capacity yet, so we don't know where they're going to go. We only know we need to start having these conversations, and that's kind of what I do. You know, I started my career telling you how to make a watch. Now I'm kind of in that season of my career where I'm talking about what time it is and how we can kind of impact, you know, the Earth's biosphere as a closed system. This is what we were all taught, that it's closed, you get a little solar energy in, photons bounce around, solar energy out. You know, it's a different world now. We can't contain all of the waste and the degradation within this circle. We need to be more sophisticated and think about the impact we're actually having on the world, and that's what the technosphere does. That's all the stuff that we're adding to it, the data centers, the energy, all of these things we have to account for when we're looking at the metabolism of a city. And a lot of the organisms and things in our cities have adjusted to our impact on the planet. They've changed their sizes, their thermal equilibrium. Plants are changing the size of their seed in response to our impact on the earth. I don't know if you're familiar with this, but this is how they're trying to argue whether we're actually in a new epoch or not. And we look to see the impact we've had on the earth. In fact, there's plutonium now in the Earth's core from when the atomic bomb went off. So we are showing that we are impacting the earth in a permanent way. And I love this slide because I like to equate a lot of things with biology because I'm a bench scientist. And you look at the man and the elephant. There's an equivalent of energy. It's not, the mouse isn't so much smaller than the elephant, but if you factor in our social metabolism, our technology, and all the energy we're using, each of us uses the biologic metabolism of 10 to 12 elephants. So I imagine the waste goes along with that. So that's something we can think about when we're looking at the power law and how it relates, because it applies to other things in population. things we see at the city level, police, taxes, lawyers, crime rates. We all know some things are superlinear, some things are sublinear, like the biologic metabolism. But cities have their own unique metabolism as well, which is kind of cool because now we know we can go to a different city and say, wow, I want to make some changes here in how the energy is used and the technology is used in a city, and you have different levers you can push. This is a bit fuzzy, but what I wanted to show you is the human capital, human-derived capital, and natural capital, and how these are conversations that happen within each other, within these human inputs and within these beneficiaries. And then we look at whoever uses the most fuel has the highest GDP, and that's just a fact. But there's also things quantitatively. In China, the workforce is different. So we have to think about that. I don't know why this is talking to us. But anyway, what this is showing us is as there's growth in economy and those learning environments, we also have growth in the way our buildings and our businesses are built out, right? We have higher managerial levels. That'll stop in a minute. And we have higher managers, and this includes growth in knowledge centers, which is also something we think about. Human population can't go on indefinitely like we show in this curve here. What's going to change? Are we going to hand species extinct this one and not that one? How are we going to change the growth? And that's a really important conversation that we have to have. As somebody who was trained up in swimming, I could be eating an optimal diet, going to the Olympics. Who's going to come to me and say, you know what, Bonnie, don't eat as many carbs or as much protein, but I want you to go faster. And that's kind of what we're asking of our world and our global system, right? We're saying, well, we're going to get the carbon imprint down. We're going to save this. We're not going to have fossil fuel. Well, then we're going to have to exchange that on growth and achievement and things like that. We just don't talk about it that way. If you're familiar with the Plimsoll line, when we see those big ships, the big cargo ships, when that line gets right under the water, that's it. The boat is at full carrying capacity. Now, if you can extend the time and the efficiency, but there comes a point where you can be as efficient as possible, and that boat's still going to sink. It's just going to sink optimally. So I like that metaphor for where we might be headed. This is, oil, fuel, energy. We all know that the conventional oil is not coming back. We're now using tight oil, which is the energy we use from fracking and things we need to do to sustain our growth. The stuff at the top there, the yellow stuff, we all talk about this as oil, but it's not all oil. A lot of this is synthetic crude, and we're already digging into that to meet our energy demands. You can see the conventional on the bottom. This is just important to understand. This is all fuel and energy, different types. And the little ones at the bottom are all like the renewable things, the things we want to build more capacity for. We just don't have that capacity yet. But I love the Sankey diagram here. So when we're saying words like fuel, we explain what that narrative means. We're not just saying energy, fuel, like it doesn't matter and that we don't have different capacities that are geopolitical. And this is Microsoft, amending their, hey, we're going to be so great in 2030. Well, they just discovered that when you build data centers all over the world, you need a lot of water to cool them, you need a lot of energy to run them, and they're not going to meet those goals. And, we think about AI. I use ChatGPT. I'm not bashing on it, but I'm just saying it uses a lot of water, and water is a resource that's not available to everyone. This is semiotics. When we look at symbols, like a red light tells you to stop, and then you stop. So we have to think about the words and the signals that we use when we say things like fuel, oil, energy. These are all different things. And I just put this little blurb in semiotics because it's foundational to quantitative storytelling. Telling story with narratives, with math, with numbers, with facts behind them to expand the conversation and invite more people collaboratively to talk about cities, infrastructure, and a lot of things a lot of us are passionate about. This is good too because it talks about the ecosphere and the Anthropocene, which we're not even sure if we're in yet because they can't agree on it. But you can kind of see the flow of energy and information and how specific it is when you're identifying a quantifiable problem. You have to talk about these things. And what I love about the work that Carl Higgs does and his team, this was his doctoral thesis, Global Health and Sustainable Cities, launched sort of by The Lancet, had a query out and they built this wonderful system. And this is just a reminder, it didn't come out so great, but like the form, the way, the morphometrics, the urban form of different cities and what that means, what the advantages and disadvantages are. And that's kind of what you explore a little bit with Carl's work and some of the Pythonic things I'm going to share with you in a moment. And this is how you start. You run your Docker, you download the software, and it's just going to be running on your computer. And I don't have a thing to point with, but you can run this in a Jupyter notebook, or you can go right to a viewer, and you don't even have to do anything Pythonic. But the Pythonic side of it, which you see here, allows you to customize this. And throughout the morning here and yesterday, we were talking about OpenStreetMap data. We were talking about the global settlement population data. You can customize this software to answer those questions. Using your YAML file, you decide what data that you're bringing on board. And that's what's so great about it. And I always suggest that people work with Carl's, example city that he provides. And if you can make that work, then you can add any of these other cities to it. But it puts things like walkability, grocery stores, fresh markets, where schools are located, where train stations are located. These are all things you build the meta layer for. The big pink box is when you want to compare urban to non-urban areas. You just have to go back and modify your YAML file, and then it runs seamlessly. So this is just what loads into the Jupyter notebook when you start running your code. I think he also has a binder file. This is just a notebook that I entered some code in and ran the software. What's going to come really fast, this is the YAML file. And this has been created for 25 cities. And I'm not going to say it all runs smoothly. You have to pick the right projections. You have to get your boundary data together. You have to really work on the metadata that you're assigning to these different YAMLs, but you have all the templates inside of this project that you're able to use. No, I can't see with them or without them. So it's kind of interesting, there was one I ran that had train stations. So you could actually, in live time, you could see traffic, you could see trains coming and going. You just have to update your YAML file and put things in correctly. And I just ran this to show it's also translated into any language you want. And from this, you'll see this in a minute, you'll get some pretty neat graphics. Oh, this also has a Postgres database that you can load right into QGIS that comes in the Docker file. So you're covered in all realms, and you can look at, neighborhood walkability, which is a big thing when we talk about our 15-minute cities. This is convenience counts, convenience stores. You could write this to be anything you're interested in. This is just what the sample contains. So whatever that metric is that you're bringing to that city query, this is how you do it, and this is the output from that data that we pull in through our metadata file and our YAML file. We can look at public transportation. This is an area in the Canary Islands in Spain, Las Palmas. We'll look at this a little additionally later on, but I just wanted to show you the fresh food markets, the type of data you get and the type of output you get. This is very popular with people who work in cities and communities, and they want to inform people of changes they want to make in the community. Intersection density, right? We all know how important it is to be able to, get around a city and how engaged people are. We also have population density, which is important. We were talking before about, highly dense buildings. Yes, maybe they use a lot of energy, but they're also great for transportation. You can have transportation networks conveniently located when you have, that sort of density. So these are just some examples, and I know I keep repeating it, but these are based on the information you ask to put into that YAML file. Pedestrian network edges. You can look at green space. How far is it to the nearest green space? There's lots of other things that you can build into the system. You can clean this up. This is just QGIS where I put that population information for 2030, and I layered it on top so I could see where those road networks are in terms of the actual population density predicted in 2030. This is the output. You get something like this, where it's a book that gives you insight and you can compare it to other locations. These are the locations that already exist. You can look up and down. There's a pretty good sampling. I include this urban form about building heights to transition into urban morphometrics, where here you can look at the convexity of different buildings. And we're going to see that graphically in just a minute. So you can actually see these things that we measure, and we can say things about the urban form. This is very popular with urban planning. And when you're trying to look at patterns and understand what a city looks like, what different areas of the city might look like, being able to look at this sort of data from building footprint data can be very valuable. And this is all open, accessible data, right? We know about the building data from Bing and Google, and that we can pull in. We also know about visualizing the data using in QGIS or whatever your viewer of, of poison, whatever your poison is. And Martin's here somewhere. Hey, Martin, looking at patterns. I like this slide because you're looking at spatial and geometric differences that are different enough but same enough that you want to compare and you want to be able to say things. And momepy is the urban morphometric tool, the details of it, all the math under it. Martin's your guy. I'm just here to tell you what time it is. So we're looking at dimensions, shapes, diversity, connectivity. When you want to look at the underlying structure of a city instead of the people that are on top of it, this can give you a lot of information of how cities are planned. And this is a beautiful illustration. We don't have a lot of time together, so I'm kind of throwing everything at you. But from just a little bit of input, you can get some pretty stellar output to answer some geometric and spatial questions and some pattern recognition around those measurements. This is a little snippet of a Jupyter notebook. I don't know why my computer's making noise. It's on silent, so just ignore all that. But this is just the code that runs. I believe Martin has a binder, so that you can just go in and launch a lot of these examples. But this is just a notebook where I look a lot at favelas, which are unstructured settlements. And what's really interesting is to see, well, what do we see if we apply this to an emergent city that hasn't been planned from top down? What type of information is there for us? Can we say things about patterns that we might view there? Can we say something about the structure of the buildings? How did they evolve over time? One thing I can tell you, having worked with favelas a lot, is they still find time to otherize people. We are human. You still find people in close to the waste treatment plant, these people closer to road networks. These sort of biases that we build out still tend to show up in some of these emergent cities, but Rosita in Brazil is very unique because what you can see about the different morphologies, they've actually built out businesses and restaurants, and they have municipal services, all from these population settlements, in which unique that you wouldn't be familiar with looking at this data is it's built into a very inhospitable terrain where it's very sloping sides. So sometimes when you're working with morphometrics, they think a field is actually a building, or they think a steep side of a ravine could be misinterpreted as a building. So I'm going to show you how I use different resources to kind of truth seek when I'm looking at the urban morphometrics of a city. The cluster analysis is what you use to develop the patterns, and you just want density in those nodes, and you want space between them so that you know that when you're looking at the cluster analysis, you're looking at things that, like those beaks, are similar but different. And this is what Rosina, the favela in Brazil, looks like, and you can see those patterns. There's definite patterns here as to where some of those smaller residential tiny homes are and where those bigger homes are. And the cluster, I just slowed it down here so you could see it more closely. If you look at 7, you can see the spread between the nodes that you kind of lose when you get to 8. And you play around with this. You find what works best, and it's you can edit it and figure out what the best distribution is and find out, does it match what you think it might, what you anticipate seeing? And here is where they looked at this. You're looking at them here on the cluster labels, and you can kind of see what things are impacted in some of these areas because you're looking at interbuilding distance. There's some things that we categorically equate with areas that might not be as advantaged. And I layered some of those networks on top of the actual satellite image of Rosina in Brazil. And you can kind of see those patterns emerge that we saw in the tessellation here. You can kind of see where those big land masses are and where the homes are on smaller spaces, because it's really important to have this cadastral view of a lot of these buildings and morphometrics. I like this in this urban settlement because it's very hard to pull data out of them unless you go and you visit and you figure out, what's happening here. This gives you that kind of sneak peek, and you can start saying meaningful things. You can go into the databases, the census. Brazil has a pretty good census where you can look at much of this data from many of the larger favelas. And then I wanted to compare it with Rio de Janeiro. So we can look not at a planned community, but we're looking at something a little more sophisticated. And I like to zoom in and look at it from Google so I know kind of what I expect to see. So we can fly along with Google Earth Studio, take a look at the Rio de Janeiro, and then we're going to just run quickly through another look at the morphometrics and the tessellation, what something looks like when it's more of a city that evolved a little bit more top-down than emergent. Because, when you look at the unhoused populations that are like roaming Brazil especially, they're creating their own communities. And you see the patterns are much more dispersed here because you have a lot more land. You have a lot more, there's a lot more diversity in these areas. When you go to a favela, you're usually looking at a certain segment of the population in terms of, poverty and opportunity. So it's really interesting to make comparisons of different types of cities, different types of communities. Martin has some really beautiful ones where you can actually look at ancient, medieval, historical, wrapped around the modernization that has happened in those different types of cities and really see those patterns emerge. And then you can start doing like some ground truth of what you think is there. This is that Las Palmas area, because if you're like me, I didn't have a lot of familiarity with that region in Spain. That is the example that's included in the Global Healthy City package. So I wanted to fly around here a little bit before I put this inside of momepy to kind of see what I might see about the city. So this is kind of an interesting look. You see a lot of these highly dense buildings in these areas, and then you can kind of look at the pattern and the clusters and see them as well. So there is these patterns that emerge from how these cities are built out. And, this was the city we're looking at, talking about walkability and talking about all these other things that we think of when we want a city to be livable, right? We want to see, road networks. We want to see ways in, ways out. We want to see the buildings. There's optimal ways for buildings to be oriented. How close are they to the street? What's the solar orientation? There's a lot of things that we want to know when we can't travel to a place to start thinking about what that might do and impact the demographics and those edges that align with the morphometry. And things like neighbor distance, covered area. These are all things that we sort of think we know something about when we're looking for like deprived areas. We want to take a look and see what those things are. And you can do this in a pythonic environment fairly readily, thanks to momepy. I don't know if we got stuck on this. There we go. And most of us who work in urban planning or with any type of building are very familiar with osmnx, which you might not be familiar with is Brasilia, which is a controversial sort of city built out according to a plan, sort of the way Paris was built out, not really with input from the people that are going to be working and living there, but from, the people on high that think, well, this is what a city should look like, and this is where we should have nodes, and this is how people should move around. And I used networks for that because it's a very big, dense data set. So this was an easy way to kind of get a look at that street network without having to load a lot into the computer. This is supposed to say 9%. I don't know why it says 14, but if you caught it, you can have a cookie in the back. These are some of the street length things we know about optimal measurements in cities and what we like to see. This is some of that betweenness centrality. We want to see, you know, how many nodes, you know, how do people move within a city? That's also very important. This is actually the favela, and you can see that red node. That's the little hot spot in the favela. That's where most of the in and out comes from. I always want to include white box software. I'm not giving it the time it needs here, but I like to just show these tools that are Pythonic and very important when looking at city and infrastructure and things that impact our environment. There's that little monkey. You know, this was funny to me, not funny, but like 10 to 20 bottles of water every time you ask ChatGPT 20 questions. You know how many dumb questions I've asked ChatGPT? And just think of the sucking sound of the water because of it. Why am I? Well, we'll have to deal with that. But I just wanted to show like how it's very easy to set up Whitebox, their Python workflow. They changed their paid tier. I don't know if you're familiar with this. There's more stuff that you can get for free, you know, and then you have to pay to get access above like the 400 tools. But I love their hydrology. I use their hydrology a lot when I'm looking at communities. And I just wanted to share a little bit about how you can run this in a notebook pretty effectively. The workbook flows are great. I'm just featuring here the example. I have a customized one that I did for a region in Utah, but just to show you how you can run it very easily in a notebook. I'm going to move into, I also run it, I prefer to run it in an IDE, like I use Spider. Maybe I'm the only one that still uses Spider, I don't know, but so what you're looking at here is the notebook rendering of Whitebox, you know, looking at the hydrology, and it's creating these little TIFF files for you, and it'll scroll down and out and over. And this is where you can just run it. This is just me running it in my, right on my computer in terminal. The only, you know, I just call up Spider. The only trick I'll tell you is make sure that however you labeled it in your hierarchy folder, you have to follow that. That's just, we all know this, but trust me, ask me how I know. So I like to run it in terminal because it's very clean. I can see all the folder hierarchy. You can use the script that will just run the whole Whitebox script. We'll run it right in the IDE, and then it generates your visual output. And then, you know, I usually just take the visual output and pull it over into QGIS and take a look around and figure out what it is that, you know, I'm interested in or what kind of story I'm telling. This is the Python script that you just pull into that, whatever you use, visual. I just like Spider because it's the one I first learned on. And you could pull it into QGIS and look at the contouring and all, whatever it is that you're excited about and you want to look at. It integrates really nicely. It's a plugin in QGIS. And this, you know, this was us. It's probably going to get loud. This is me in France taking the gondola up over Mont Blanc. And what I thought was really interesting about this is the immensity of it. Just these glaciers are melting at an alarming rate. And we all hear about glacier melt. And then you go flying up the mountain and you see it, and it's so profound. And on that little ridge there, those are people that you see hiking across there. It was just breathtaking. I spent 9 days in Chamonix before coming here, running on the trails, and it just was so humbling looking at the great, you know, the world. This cracked me up. I saw this on BBC, where on the side of the sun, you see this ultramagnetic radiation. And to me, it looks like a question mark. Like the sun is like, what the hell are you doing down there? You know, like, so I don't know if you've seen this in the news. I just thought it was really funny. That's me. I don't know if we have any times for questions, but I wrote a book. I'm not trying to sell the book. I'm just saying Python for geospatial data analysis. And, you know, we have open conversations about those topics over on Substack.
Thank you very much. we do have 2 quick minutes for questions if anyone wants to ask anything. I think everyone is just too keen to go and get coffee now. So thanks very much.
Everybody else, they want to run for coffee?
It is time for the coffee break now, so we will be starting again in half an hour. All right.